When we look up at the night sky, there is one planet, which with its unique red glow, symbolized war and deities in ancient civilizations. That is Mars. Today, it represents the ultimate dream of our human civilization, migrating to Mars. We are not discussing a sci-fi movie. We are discussing a colonization plan that is already on the agenda. Throughout human history, a great geographical coordinate emerges every so often. From Columbus discovering the New World to humanity's first moon landing, the next one is undoubtedly Mars. But Mars is more than just Earth's backup. It is a new world, a place waiting for us to define the boundaries of humanity. Imagine your child learning to walk in the low-gravity environment of Mars, or your grandchild sipping coffee under a Martian sunrise. This is no longer a distant fantasy. To achieve this interplanetary dream, the world's leading space agencies and commercial companies are engaged in an unprecedented race. So, when can humans truly set foot on Mars and begin permanent residence? And how will we overcome the deadly challenges of the Red Planet? Today, we will unveil the timeline for human settlement on Mars and the most realistic, brutal conditions for survival there. After watching this video, you will know the price of becoming one of the first Martian colonists. Achieving permanent human residence on Mars is a grand, multi-stage project spanning several decades. Its timeline is primarily determined by two major driving forces: national space agencies, such as NASA, and commercial space companies, such as SpaceX. NASA's strategy is Moon first, then Mars. They are returning to the Moon through the Artemis program to establish a lunar outpost. The Moon will be viewed as a staging post or test bed for the Mars mission, used to test life support systems, radiation shielding technology, and deep space communication. NASA's official window for a crewed Mars mission is generally set for the late 2030s to early 2040s. This is a more cautious, lower-risk, government-led long-term strategy. The goal of this phase is short-term scientific exploration, data collection, and preparation for the site selection and design of a permanent base. Elon Musk's ambition is more aggressive. His goal is for the Martian colony to achieve self-sufficiency within a human lifetime. His key technology is Starship, the fully reusable heavy-lift rocket that is the foundation for large-scale colonization. SpaceX plans to complete its first crewed Mars mission in the late 2020s, targeting around 2029. They will first conduct large-scale uncrewed cargo missions, sending life support systems, power stations, and construction materials to Mars to prepare for the arrival of humans. Overall, human presence on Mars will go through the following key stages. First is the uncrewed cargo and prelude phase, from now until the early 2030s. The focus is on deploying in-situ resource utilization, ISRU, technology. Uncrewed spacecraft will deliver equipment for generating oxygen and water, proving that we can be self-sufficient on Mars. Next is the first crewed landing phase, in the 2030s. The first humans will land on Mars, typically small teams of scientists and engineers, for short-term stays lasting several months. They will activate pre-deployed bases and conduct critical experiments. Then comes the outpost establishment phase in the 2040s. A semi-permanent, scalable Martian base will be established. The base will have the capability to grow crops, extract water ice, and provide radiation shielding. Humans will begin living on Mars as explorers. Finally, the permanent colony and self-sufficiency phase in the 2050s and beyond. The colony will expand, with the population reaching hundreds or even thousands, forming a Mars village or Mars city. The key is achieving localized production of most supplies and establishing Mars's own economic cycle. At that point, humanity will truly become Martian residents, an interplanetary species. If you had a chance to immigrate to Mars in 2040, knowing you might never return to Earth, would you go? Write your answer in the comments. Regardless of the timeline, once we step onto Mars, humans will face the most extreme survival test in the universe. Next, let's delve into what humans will rely on to survive on Mars. Environment. The harshness of the Martian environment far exceeds our imagination. It has no Earth-like blue skies and green lands, only a thin atmosphere, lethal radiation, and extreme cold. We must rely on technology to create possibility in the impossible. The density of the Martian atmosphere is less than 1% of Earth's, and 95% of it is carbon dioxide. Humans need to wear spacesuits for outdoor activity. However, in-situ resource utilization, ISRU, technology can be used. One of the most important is the MOXIE experiment, which can separate oxygen and carbon monoxide by high-temperature electrolysis of Martian carbon dioxide. This process proves that we can self-produce oxygen. Future bases will rely on large, continuously running MOXIE systems to maintain a breathable environment within the habitat and supply oxygen for spacesuits. Oxygen is not only for breathing, but also the fuel oxidizer for rockets returning to Earth. Without water, there is no life. But the good news is that Mars is rich in water resources. Martian water primarily exists as water ice in the polar ice caps and shallow subsurface, especially in the mid-latitudes. The colony will need huge drilling equipment and heating systems to excavate the water ice, then melt and purify it for residents to drink, use for growing crops, and, most importantly, electrolyze into rocket fuel. Water on Mars will be key to the colony's self-sustenance, as it simultaneously solves three core needs: drinking, farming, and energy fuel. The Mars base must rely on aeroponic or hydroponic systems to grow food in completely controlled, closed capsules using soilless cultivation techniques. Examples include potatoes, leafy greens, and algae. These systems can maximize water savings and efficiently utilize light sources. Martian soil, known as regolith, contains perchlorates that are harmful to humans and lacks necessary organic nutrients. In the future, scientists may develop methods to wash away perchlorates or use microbes to fix the Martian soil before true outdoor agriculture can be achieved. Mars lacks Earth's magnetic field and thick atmosphere, meaning cosmic rays from solar flares and deep space directly hit the surface, a lethal threat to human cells. Humans cannot live in exposed metal capsules on the surface. Initial habitats may be inflatable, flexible modules, but they will eventually be covered with a thick layer of Martian regolith, or built directly into underground lava tubes or artificial shelters. The thick layer of soil can effectively act as a natural radiation shield. Additionally, the habitats themselves need to use hydrogen-rich materials, such as polyethylene, to absorb neutrons and further enhance protection. Mars's gravity is about 38% of Earth's. This seemingly benign number is the invisible killer for long-term astronaut survival. Prolonged exposure to a low-gravity environment leads to bone density loss, muscle atrophy, optic nerve damage, and cardiovascular system problems. Although these effects are less severe than on the Moon, they still pose a significant challenge. Therefore, Martian residents must strictly adhere to exercise regimens, including wearing special weighted suits and using equipment like centrifuges within the habitat to simulate Earth's gravity to maintain bone and muscle health. After solving the physiological and environmental challenges, we must next consider a deeper question: how will a Martian colony achieve economic and spiritual independence? Living on Mars is not a charitable project continuously funded by governments. A permanent colony must achieve economic self-sufficiency. Mars can become a staging post for asteroid belt mining and deep space exploration. Rocket fuel prepared on Mars can be sold to other interplanetary missions. In the future, it might even export ultra-pure materials manufactured in the low-gravity environment. The results of biological, physical, and medical research conducted in Mars's low-gravity, high-radiation environment will be humanity's most valuable asset. The communication delay between Earth and Mars ranges from 3 to 22 minutes, which means a Martian colony must be autonomously managed. They cannot wait for Earth's commands or aid. The colony will need its own laws and its own decision-making system to handle emergencies and daily governance. In a sense, the Martian colony will be the first civilization in human history truly independent of Earth. This is not just geographical separation, but political and cultural detachment. For the first humans born on Mars, their bodies will adapt to Mars's low-gravity environment. Their bone, muscle, and internal organ structures will exhibit subtle but irreversible differences from Earthlings. They may never be able to withstand 100% of Earth's gravity. This is not just a survival issue, it is an evolutionary one. Martians will no longer be Earthlings. Mars is the starting point for humanity to become an interplanetary species. It is not an easy journey, filled with risk, challenge, and immense cost. But just like the navigators 5 centuries ago, our exploratory footsteps never cease. Martian colonization is not just a project for scientists. It is humanity's ultimate insurance, a backup plan to ensure our civilization is not destroyed by a single planet catastrophe. It represents the highest will of human civilization, never yielding to the environment, perpetually exploring outwards and constantly seeking a new home. If you enjoyed today's deep dive into space exploration, please give this video a like. It's the biggest encouragement for us. What is your greatest concern about Martian colonization? Do you think humanity will ultimately succeed in establishing a self-sufficient Martian civilization? Leave your thoughts in the comments, and I will personally engage with you.